Hi everyone, welcome to the notes for 2-5. Our lesson today is on summation and sigma notation. The Greeks gave us pi to represent that very important number you all know so well. We also typically use Greek letters to represent angles in geometry. Theta and phi are just two to name right now. And then there's delta y over delta x, which we use in our formula for slope. Today we are going to reintroduce another important letter from the Greek alphabet, and that is our sigma. You did learn about sigma in Algebra 2. That's when you were finding the sums of series. Today we're going to study it a little bit more. So sigma notation. The capital Greek letter sigma is the equivalent of the capital letter S in the English language. And it's used in mathematics as a compact way to indicate sums. We use sigma notation, or also known as summation notation, as a shorter way to write a long list of numbers or terms that are being added together. Here's an example below. You'll see the sigma symbol right here. There is a little letter down here underneath where it says K, and then it says K is equal to 1, and above it you'll see a 3. Right next to sigma, you'll see the expression K squared. Okay, so this is our sigma notation. We know that we're finding the sum from the first term to the third term of the series that's defined by this function rule, K squared. So you'll see there, our first term would take 1 and plug it in, so we have 1 squared, plus our second term would be 2 squared, plus our third term would be 3 squared. When you find the sum, you get 14. Now each of these parts has its own little reason for being there, and we can call some of them by name. So first of all, K squared, our function rule, is what we call the argument. That's what's known as the argument. Where our K is located on the bottom, there is what we refer to as the index. So that's going to tell us what term we're going to start with from our series, and then above it's going to tell us what term we're going to end with. Remember that your values for K can only be integers. We can't have the 2.5th term, right? So it's 0, 1, 2, 3, 4, 5, or you could even have like the negative third term if you wanted to, but there are no decimals or fractions. Write the following sums in expanded form, then calculate each sum value. So it's asking us to write it out in expanded form. You need to know what this means. We have to find the sum from the third term to the sixth term of the series that's defined by this rule 2 to the power of j. Let's think about that for a second. We're finding the third term, the fourth term, the fifth term, and the sixth term, and then we're going to add them all together. To get our third term, let's just plug that 3 in for j. So instead of being 2 to the power of j, it's 2 to the third power, plus 2 to the fourth power, plus 2 to the fifth power, plus 2 to the sixth power. Now what do we get when we do that? Well, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32, and 2 to the sixth is 64. We'll add all those together and we should end up with 120. All right, the next one. We're finding the sum from the second term to the fifth term of the series that's defined by this expression, 4n squared plus 2. So we're finding the second term plus the third term plus the fourth term plus the fifth term. So there's 4 terms here. Let's go ahead and expand it. We'll say, and what I would suggest to you is this. Let's take this and kind of draw out a template. We know that we're going to be substituting this value in for the n in these expressions. Let's just set it up here. We know there's going to be 4 expressions, so we're going to say 4 times blank squared plus 2 plus 4 times blank squared plus 2 plus, and we can, if we write out our template this way, it makes it a little easier, in my opinion, not to write in our number in the wrong spot, because occasionally that will happen. So you see we have 1, 2, 3, 4 spots. So the values that are going to go in there are 2, 3, 4, and 5. So we've got 4 times 2 squared plus 2, 4 times 3 squared plus 2, 4 times 4 squared plus 2, and 4 times 5 squared plus 2. And now we're just going to look to find the sum of those values. Well, 2 squared is 4 times 4 is 16 plus 2 is 18. The next one, when you plug in the 3, we should end up with 38. When we plug in 4, we should end up with 66. And when we plug in 5, we should end up with 102. We add those all together, and we should get our sum is 224. Now, how can we use a calculator to check this? I'm not going to use the 84 or the Inspire right now. I'm going to go ahead and just use the Desmos graphing app because it's free and everybody can have access to it at the moment. To do a summation on Desmos, you're going to find the Functions button on the keyboard. Click it. It brings up a menu, and you want to go all the way over to the right column for Miscellaneous. Then at the very bottom of the center column, you'll see Sigma. Go ahead and click it. So now it says you're finding the sum from blank term to blank term. Well, let's check the one that's on our paper. Let's check this one right here. Let's let n equal 2, and then we're going to the 5th term, so we'll put that on top. And here's where I need you to listen to me. You'll notice in our problem, this has parentheses. You need to make sure you put parentheses around the entire argument because the calculator will read it as expressions if you do not. So it may leave part of it off, and I'll show you what I mean in just a moment. So we're going to go ahead and put in parentheses, and I'm going to say 4. And since our index is n, we need to go in and choose n. We're going to go back and square it, and then say plus 2. And you'll see there that it gives us the answer already as 224. And that's the same thing we got here. Now let's say for a moment you did not put the parentheses in. I'm going to delete the parenthesis, and then I'm going to arrow over and delete the other parenthesis, and I want you to watch the sum value is going to change. Notice it went down to 218 because all the calculator is reading right now is the argument is 4n squared, and you're just adding 2 to the argument. So make sure you're careful about that and that you actually put parentheses around the entire argument when you enter it in. All right, let's jump into the notes again. And I will tell you in class how to do it on the 84 and the Inspires. Either that or I'll make a little video and add it separately to Schoology. The next slide says, write the following sums in expanded form, then calculate each sum value. So the first one, we're finding the sum from the first term to the third term of the 16 times 1/2 to the power of k. Let's do it. So our first term would end up being 16 times 1/2 to the blank power. How many terms are we going to have here? We're going to have a term 1, a term 2, and a term 3. So I'm going to set up that template. There's our 3 terms. And we know that the first one would be 16 times 1/2 to the first power. The second one would be 16 times 1/2 to the second power. And then we'd have the third power in the third one. And all we need to do now is simplify those and add them together. Well, 16 times 1/2 is 8, plus 16 times 1/4 would be 4. 16 times 1/8 would be 2. So we add those all together, and it looks like the sum is 14. And you may check it on your calculator if needed. Let's go to the second one. We're finding the sum from the negative first term to the fourth term, which means we're looking at the negative first term, the 0, first, second, third, and fourth. So it looks like we have about 6 terms in this one that we need to expand out. Let's do it. I'm going to set up a little template here. I'm going to have 3 times blank plus 1. And then we're going to add to that 3 times blank plus 1. So remember, if it's asking you to expand it, this is what you have to do. Okay? It's not like, hey, I'm going to go type it in the calculator and just get the answer. No, if you're asked to expand it, you got to do this part. So we're going to plug in negative 1 into the first one, then a 0, then a 1, then a 2, a 3, and a 4. And then we'll just find our sums for each of them. First one looks like we've got negative 2 plus a positive 1 plus a 4 plus a 7 plus a 10 plus, looks like 13. And we add all those together, and it should end up being 33. And you're welcome to check that one on the calculator. Let's do the last one on the bottom here. We're finding the sum from the first term to the fourth term. So how many terms is that? 1, 2, 3, 4. 4 terms. Notice this one has 2 m's in the argument. So that means we're going to have to plug in our term numbers into the expression for both of those m's. So let's see here. We've got 1 over something times something plus 1 plus 1 over something times something plus 1. I think I'm adding all kinds of weird things in there now. So let's just take it and plug it in here. So the first one we'd say 1 over 1 times the quantity of 1 plus 1, 2's, 3's, and 4's. As we look to simplify it down, the first one is going to be 1 over 2. The second one will be 1 over 6. The third one will be 1 over 12. And the last one will be 1 over 20. Well, to get the sum, we're going to need a common denominator. What do 2, 6, 12, and 20 all go into? If you said 60, that's correct. So 1/2 is going to be 30 60ths. 1/6 would be 10 60ths. 1/12 would be 5 60ths. And 1/20 would be 3 60ths. We add those all together and we're going to get 48 60ths, which reduces to 4/5. And that is our answer for that one in terms of the sum. All right, hang in there. We're almost through it. Let's go through a little bit more. Now we're going to look at trying to write out our sigma notation or our summation notation. It says find a rule or equation for a linear function f in slope-intercept form such that f of 2 equals 6 and f of 5 equals 15. First of all, what does this mean? And what does that mean? F of 2 equals 6 means the point 2, 6. F of 5 equals 15 means the point 5, 15. Now you can plot each of those on your graph if you want to. But you could use that to find the slope as well. We could say m is going to equal 15 minus 6 over 5 minus 2, which gives us 9 over 3, or 3. Means we're going to go down 3 and back 1 if you want to put some more on here. Okay, so the next part of this, right, we're trying to come up with the rule or the equation. Well, it looks like our y-intercept is 0, and our slope looks like it's 3. So our function here should be f of x is equal to 3x. You could say 3x plus 0, but I think 3x works just fine. Okay, and let's go ahead now and look at the bottom. It says use the result to express 3 plus 6 plus 9 plus 12 plus 15 in sigma notation. Okay, so what it's asking us to do is to relate this function to this series. And the way we have to think about that is this, right? My x and my y. My x is like my term number, y is like my term. In terms of this function, right, my 0th term would be like 3 times 0 is 0. My first term, when I plug in 1, I get 3 out. When I plug in 2, I get 6 out. When I plug in 3, I get 9 out, and so on. So this is like our first term, our second term, our third term, our fourth term, our fifth term. So we've got this expression, 3 plus 6 plus 9 plus 12 plus 15, or that sum, we're going to represent in sigma notation. So we're finding the sum from the first term, so where x equals 1, to where x equals 5, right? So from the first term to the fifth term, that's what we're putting in there. And then our function rule is simply this 3x. So we'll take that and we'll put 3x in there. Okay, now if we want to take it there and we wanted to expand it out, right, just think about what that would look like, right? So we'd be saying 3 times something plus 3 times something. We'd have 5 of those, right? So it would end up being the first term, second term, the third term, the fourth term, and the fifth term. And when you do that, you have 3 plus 6 plus 9, just like above. So I just want you to be able to make that connection about how this is all working. If we want to know what the sum is, go ahead and add it all together, and we should end up with, I believe it's 45. Okay, so if you have questions about that, please make sure you mark them down, and we'll continue to work on it. So here's another practice one. It says write the series 5 plus 7 plus 9 plus 11 plus 13 in summation or sigma notation. So again, that means this is the first term, second term, third term, fourth term, and fifth term. Now you're welcome to take it and find the slope. Okay, you can see that it's got that constant rate of change happening. So you could find your slope that way by doing 7 minus 5 over 2 minus 1. And that tells us that it's changing by 2 each time, which we can obviously see, but we're just trying to be basic so we can look for the method. Okay, we would also probably need to know what our 0th term is, right? So if we went back this way too, we know that that would be 3. So our b would be, I'm sorry, not 0, it would be 3, I just said, didn't I? Woo. Okay, now, so you could take that and you could say, all right, well, my f of x is equal to 2x plus 3. And that's one way to find our function rule. I want to show you another way to do it though. Okay, so what we have here is a list of points, right? The point 1, 5, 2, 7, 3, 9, 4, 11, 5, 13. We also figured out what the slope was. Let's look at it as we have a point and a slope, and let's use the point slope. I just want you to understand some of the uses for this formula that we've come up with, the point slope form. Remember, that is y minus y sub 1 is equal to m times the quantity of x minus x sub 1. Let's take it, let's put in our slope. You know that is 2. And for the rest of it, I want you to choose a point, one of these points, like say 5, 13, 4, 11, 3, 9, 2, 7, or 1, 5. Choose one of them. Choose a random one, and let's plug in the x for the x sub 1 and the y coordinate for the y sub 1, and let's see what you get. I'm going to use the point 411. So if you use that one, so sorry. Right? So if I take it here and I'm going to say y minus 11 should equal our slope times x minus 4. If I want to figure out what the function rule is, okay, look, it'll help me get it by just simplifying. Let's go ahead here and distribute our 2 through. So we have 2x minus 8, and right now that equals y minus 11. Let's add the 11 across to get it into like slope-intercept form, or where the outputs are by themselves. And you see you get y equals 2x plus 3. Now, hopefully you did a different point up there, but you should have ended up with that same rule. So this is a use for point slope. Rather than having to count backwards to find our y-intercepts, if you just take a point and the slope you know, and you plug it into this formula, you can simplify it and it'll give you the same answer. All right, let's take that now. What are we going to do with it? Well, remember, we're finding the sum from the first term to the fifth term. So let's set up our sigma. We're finding the sum from the first to the fifth. Now, you can use whatever letter you want for the index. Let's say on this one I want to use n. I'm going to say we're going from the first term to the fifth term of the function. Now, I don't want to use x if I used n down here. You got to make sure you use the same letter. So I'm going to say 2 times n plus 3. That's how we would write out our sigma notation. If you want to expand it, you're just going to do 2 times blank plus 3 plus a 2 times blank plus 3 plus 2 times blank plus 3. And I'm not going to go all the way through this one. You get the idea now, right? B1, B2, B3 until you got across there. Then you add them all up. And in this case here, I believe that the sum actually ends up being 45 on this one as well. All right, let's jump in here. Last little bit. We've got use the following sum to answer the questions. So we have 10 plus 8 plus 6 plus 4 plus 2 plus 0 plus negative 2. Write a linear function that would produce these values. All right, so I'm going to go ahead here with this one. And I'm going to think of this as the first term, the second term, the third term, the fourth term, and so on. So it looks like it goes all the way to the seventh term. If I want to write that linear function, first of all, can I find the slope? If I find the slope here, I've got m is equal to 8 minus 10 over 2 minus 1 would give us negative 2 over 1, or negative 2. I'm going to use my point slope to come up with this. I'm going to say y minus y sub 1 equals m times the quantity of x minus x sub 1. And I know you could probably just take it and add 2 and get to 12. That's fine. But if you never practice this, you're never going to remember it. So just take a random point that's on there. I'm going to use the fifth term as 2. And I'm going to plug it in and say y minus 2 is going to equal my slope negative 2 times x minus my fifth term number. Simplify it. Negative 2x plus 10 is equal to y minus 2. And again, you'll see y is equal to negative 2x plus 12. Okay, same thing you would have got if you had counted backwards, but you're not always going to be given the first term. Sometimes you're going to be given terms way off down in the series. So the point slope form will help you out in that respect. So there is the function. Now it says use sigma notation to express the sum. So put your sigma in first. Choose what letter you want to use. I'm going to use n in this case. We're going to say let's go from the first term to the seventh term of this function, negative 2 times n plus 12 So we've expressed it there like that. And, we don't actually have to take it and do it all the way out. Let's practice doing it on the calculator once. So let's go in and I'm going to pull out my Desmos Calculator. Okay. So with this one, remember, again, function, go over to miscellaneous. There's sigma at the bottom. We're going from the first term to the 7th term, and we need to put the parenthesis in there. We're going to say -2. Go find your n, and then plus 12. And enter there, and it looks like our sum is 28. Now, what changes would you make in the notation if it looked like this? If it was 6 plus 4 plus 2 plus 0. So let's just think about what's going on. Right, you'll see some of these numbers overlap. Right, we had 6, we had 6, we had 4, 4, and so on. So we know that 6 really is the third term because it was the third term in the series up here. So now we're finding the sum from the third term all the way to, what is this going to be at the very end? What is -6? Well, this is 4, 5, 6, 7, 8, 9. So if we're going to change our sigma notation, we're still using that same rule, but now we're going to find the sum from the third term to the 9th term. So we'll write it like this. So we're going to find it from where n equals 3 to where n equals 9. So from the third term to the 9th term of this same function rule. And that's how we would change it there. If you want to go ahead and do that, you can find the sum just using your calculator. So we'll go back in one more time. We've got sigma there. We're going from the third term to the 9th term. And we're doing our -2n plus 12. And in that case, you'll see it ends up equaling 0. And I guess we could have just looked at it and realized that 6 and -6 would cancel, 4 and -4 would cancel, 2 and -2 would cancel, and you'd be left with 0. All right, so hopefully this makes a little bit of sense to you there and you feel okay with it. If you have questions, you need to ask because it's only going to get harder from this point forward. Thanks for watching.